Here's a quick video about the reference angle and also just a little bit of more generality about the special angles on the unit circle. These are not the only angles we're ever interested in by any means, but they're the ones that are going to be our home base, the ones we want to memorize, and it's a good start. For example, this is one of the special angles we know. If this angle in here is 30 degrees, that's what this 30 degrees is supposed to mean, or in other words in radians this is pi over 6, 1/12 of a circle, then we figured out basically by dropping a perpendicular. I'll go ahead and do that. If you drop a perpendicular to here, then you get a 30, 60, 90 triangle. And that means we know the ratios. We know that the radius here is 1. This is the unit circle. That's what's special about this circle. And using the ratios, we figured out that this has x-coordinate √3/2 and y-coordinate 1/2. That's a way to figure out all three of these very special angles in the first quadrant. And let's stick with this one for a minute. What about in other quadrants? So for example, what about over here? Well, what we can observe is that if you go directly through and opposite from this point that we do understand, you can get to here. We can use that to figure out both the angle information and the coordinate information. So let's see. In terms of angle, we go all the way around 180 and then plus exactly the same angle or the same arc of the circle as we did here. Okay? So that's going to be 180 plus 30. That's going to be 210 degrees. So this guy is 210 degrees. In terms of radians, which is really our preferred measure, but we're still getting used to it. Whoops, that's not what I meant to do. Well, good enough. Okay, in terms of radians, what are we doing? We've got pi to be half a circle plus the pi over 6, and that's going to be 7 pi over 6. 7 pi over 6. I guess I should have just done a control Z there a minute ago. That would have helped me out. Okay, now let me see if I can actually sync this up better. It's weird how the text doesn't move. I like Geometry Sketchpad in some ways, but you know, in some ways it's just ridiculous. Sorry, guys. Okay, so what about the x and y coordinates? Well, we were a half up from the axis, and now we're on the opposite side. That's going to be a half down. We were √3/2 to the right. We're going to be √3/2 to the left. So we're just going to get the signs changed. In fact, what I can do, let me just copy and paste that thing. Boop. And then change the signs. Minus and minus. Okay. And delete that thing. Okay. So that's all the information we need about this one. It's the 7 pi over 6 point on the unit circle, 210 degrees if we like degrees, the x-coordinate minus √3/2, the y-coordinate minus 1/2. But there's a we want to sort of emphasize the fact that it really came from this information, and one terminology for that is to talk about the reference angle. And basically that means draw the same kind of right triangle that we had before. So let me go ahead and do that perpendicular again. And just focus on the segment here. Didn't do that right. There we go. Okay. So now we've got this triangle, and this triangle is just congruent to this one. And that's another reason, another way to say why these numbers came out the same, except just with different signs. Just because the directions were flipped. The basic geometry is not different. And what we say is that this angle in here, this is 30 degrees again, because it's still a 30, 60, 90 triangle. And this data of √3/2 1/2, already we knew it was associated to 30 degrees. And so what we call that is the reference angle. So in here, let me just put in a little text box in here, 30 degrees, or equivalently, pi over 6. That's called the reference angle. So let me write that. By definition, it is the angle between where you are on the unit circle, wherever quadrant. It's the smallest angle. It's the quickest way to get to the x-axis. Really, really important. x-axis. Let me write that down. It's to the x-axis. If you do it to the y-axis, you're going to get things screwed up. Okay. So any place on the unit circle you look at, you draw a perpendicular to the x-axis, you look at what that angle is between your direction and the x-axis. That's going to be a reference angle. That's going to be something between 0 and 90. You can never get more than 90 degrees away from the units from the x-axis. And that means that if you take that reference angle, that's going to say that you've drawn a triangle, whatever your triangle is, it's going to be congruent to the same one up here with the reference angle. Let's do another example using this reference angle terminology. Let's look here. Well, this is the halfway position between vertical and horizontal in this third quadrant. Let's not worry about what the actual angle is right now. Actually, well, let's do that first. But then we're going to use the reference angle terminology. Okay, so it's 90, 180, 270 plus another 45, so that's 315. So that's going to be 315 degrees. If we like degrees, we really like radians better, so let's do it in radians as well. It's going to be, what is it? Pi over 2, pi, 3 pi over 2, that's 6 pi over 4 plus another pi over 4 is 7 pi over 4. Okay. So, but what's the reference angle? The reference angle is this, the angle in this triangle. I'll just make that right now. Go ahead and construct that perpendicular. Oops, parallel. Oh, it's got the text box selected. It doesn't like to do things with text boxes. Perpendicular, there we go. Okay. So here's the triangle that we care about. Let me just hide this puppy. It's too busy. I will do that. Let's try that again. So that's the thing about Sketchpad. Good if you use Sketchpad. What happened there is I had a bunch of stuff selected. I didn't deselect first. So I want to construct my segment. Then I've got to deselect. Then select only the thing I want, and then I'm hiding it. I'm doing a Control H, by the way. Okay, so now here's the triangle. It's a 45, 45, 90 degree triangle. There's a 45 degree angle in here. So here's the claim. It turns out one of the things we know that we figured out already is that the 45 degree position in the first quadrant has coordinates root 2 over 2, root 2 over 2. Because this reference angle here is 45 degrees, or pi over 4, the shortest angle to the x-axis is pi over 4. That means that whatever these numbers are, they are going to be, except possibly for the signs, they're going to be exactly the same as the triangle up here. So all we have to know is 45 means root 2 over 2, root 2 over 2 in the first quadrant. And we know that that's going to give us the same thing, root 2 over 2, root 2 over 2. But then we just have to fix the signs. And why is that? It's because this triangle is just a flipped version of the triangle we would put here. I forgot to put it in, but that's okay. So these numbers come from the geometry of a 45, 45, 90. Well, here's a 45, 45, 90. It's just flipped around. And let's see, what are the signs? We can just get that by the quadrants. This guy is in the fourth quadrant, so x is positive and y is negative. Okay. So that's an example of using the reference angle. You don't have to think of it that way, but it's not a bad way to think about it. And we'll often refer to, if I've got an angle somewhere in the other quadrants of the circle, what's that reference angle? It puts things back in the 0 to 90 range. And it refers to the absolute basic ones that we were figuring out in the first quadrant. Okay.